Okay, this will likely be the shortest video I ever make. Just 2 questions in the problem set for 10.1e, but both important concepts. Number 6 wants to know which formula is that of a secondary halogenoalkane. So I have to look at where the halogen is attached and what else is attached to that carbon atom. So when I look at the first one, I can see pretty easily, even without drawing this, that the bromine is going to be attached to this last carbon, and then that carbon is attached to 2 hydrogen and 1 carbon, so that's going to be a primary. In B, it appears that I have a CH3 group, a CH group, a CH2 group, and a CH3 group, so my bromine is here. And this carbon is attached to 2 other carbons, so this appears to be my secondary one. And if I just double check, this one I've got 2 CH3 groups attached to this CH group, like so, which is attached to another CH2 in the bromine, so this is also primary. And the last one, I've got a carbon attached to it, but then each carbon is attached to a CH3 group, so this one's tertiary. So B is my only secondary halogenoalkane. And then number 7, it says, describe the bonding in benzene and use it to explain benzene's energetic stability. So benzene is an unusually stable molecule, which is one of the reasons they realized it must be a ring chain instead of a straight chain. So ring versus straight would be more stable, which is the same as saying less reactive. But then the other thing is that alternating double bonds, like we thought benzene was for a long time, double and single bonds. So I've got my benzene like so, and for a long time we thought we had these every other double bonds, and we thought they just rotated around, so that we often drew it like this, showing the rotation. But alternating double and single bonds would still be more reactive than it is. So we say more than benzene is observed to be. So this gives evidence or support to the idea that these double bonds are actually delocalized electrons. And it actually functions more like a metallic bond does with the sea of electrons there. So we have experimental evidence showing that both these things seem to be true. It's far less reactive than a straight chain would be with 6 carbons and alternating double bonds. And even as a ring chain, it's less reactive than we would expect if there were truly alternating double bonds.